So, introduction. Newton's law of cooling or warming states that the rate of change of the temperature of a body is proportional to the difference between the body temperature and the surrounding temperature. The model is expressed as dT over dt equal to K bracket T minus Tm bracket, where T bracket T is temperature of the object at time T, T bracket M equal to temperature of the surrounding object, and K is a constant of proportionality, and dt over dt equal to the rate of change.
Hey, what are you watching?
I am watching about the crime investigation movie. The detectives are trying to determine the victim time deal.
Wow, sound interesting.
Yeah, actually, let's solve the case ourselves.
Sure, what's the case?
First, cooling. A 70-year-old man was found dead at home by the forensic team at 8 p.m. The forensic team measured the body temperature and found it to be 30 degrees Celsius. The room temperature at that time was 24 degrees Celsius. After 1 hour, the body temperature was measured again and had dropped to 28 degrees Celsius. Assuming the normal human body temperature before death is 37 degrees Celsius, determine the estimate time of death using Newton's law of cooling. Next, calculation. We gathered all the information that we got from the question. dt over dt equal to Kt minus 24. 24 is the room temperature at that time. We separate the variable and integrate both sides. Then the general solution is T equal to 24 plus Ce power of Kt. Next, we find the value of C. Thus, T equal to 24 plus 6e power of Kt. Next, we find the value of K. We substitute the T and the temperature. Then we get T equal to 24 plus 6e power of negative 0.4055t. Next, we find the time of death. We substitute the normal human temperature, which is 37 degrees Celsius. We get T equal to negative 1.9 hours. So, time of death is 8 p.m. minus 1.9 hours. We get 6 p.m.
Nice, we solved the case.
Oh no, my drink!
Me too! We have been busy solving the case that we left our drink sitting here.
You know what? This reminds me of another Newton law problem.
Let me guess. Now instead of a body cooling down, the drink is warming up.
Exactly. Since the ice has already melted, the drink will gradually warm up.
Oh.
So, we can use the same principle to figure out how long the drink have been left on the table.
That's right. If we know the room temperature and measure the drink temperature over time, we can estimate when we left it here.
Wow, Newton's law is useful for more than just crime investigations.
Alright, detective, what's the next problem?
Let's find out.
After solving the time of death calculation using Newton's law of cooling, I suddenly realized that I had forgot about my iced coffee from Kenangan Coffee. The coffee was initially at a temperature of 6 degrees Celsius and had been left on a table in a room maintained at a constant temperature of 18 degrees Celsius. After 25 minutes, the temperature of the coffee increased to 10 degrees Celsius. I want to find about the temperature of the coffee after 1 hour and also the time required for the coffee to reach 15 degrees Celsius.
Let's solve this together. We apply Newton's law of cooling and warming. We let T represent the temperature of the coffee at any time T. The rate of change dt over dt is proportional to the difference between the coffee temperature and the surrounding room temperature Ts, which is 18 degrees Celsius. Separating the variable and integrating both sides gives us the natural log equation ln t minus 18 equal to kt plus c. By rewriting this in exponential form, we get our general equation t equal to 18 plus ce power of kt. Now, let's find our constant. Using our initial condition at T equal to 0, where the temperature is 6 degrees Celsius, we find that our constant C equal to negative 12. This gives us the equation T equal to 18 minus 12e power of kt. Next, we use our second clue at 25 minutes. The temperature is 10 degrees Celsius. Plugging these values in allows us to isolate e power of 25k, and by taking the natural log, we calculate our cooling constant k to be approximately negative 0.0162. With that, our complete predictive model is t equal to 18 minus 12 e power of negative 0.0162t. First, let's find the temperature of the coffee after 1 hour, which is 60 minutes. We substitute T equals 60 into our formula. Evaluating 18 minus 12 e power of negative 0.0162 multiplied with 60 reveals that after an hour, the coffee will have warmed up to 13.46 degrees Celsius. Finally, let's find out how long it takes to reach 15 degrees Celsius. We set our target temperature Tt to 15 and solve for T. Moving 18 to the other side and dividing by negative 12 gives us 15 negative 18 over negative 12 equal to e power of negative 0.0162t. Taking the natural log to clear the exponential, we find that T equals to 18.57 minutes.
Lastly, conclusion. Why cooling and warming is important to our life? Cooling and warming are important because they help us understand how temperature change over time. They are used in many real-life situations, such as forensic investigation, food preservation, healthcare, and daily activities. By understanding this concept, we can predict temperature change and solve practical problems more effectively.